Hello everyone. Hi. I hope everyone is able to see me properly. You can actually let me know in the chat. Are you able to see me? Yes. Great. Yep. All good. Are you able to see me? Are you able to hear me? Welcome to the first class. Yes. Guys, a quick thumbs up. Are you able to hear, see me properly? All good? Hello everyone. Hi. I hope everyone is able to Guys, come on. Yes, awesome. Thank you so much for confirming. Let's quickly give 5-10 minutes for people to join because it's the first class. I guess people will just need some time to get used to this. Remind everyone on Discord to join. Thank you so much for showing up on time. Really means a lot to me. Today we'll wait for 3-4 minutes for people because it's the first class. Otherwise we'll start at sharp 9 every day. I'm so excited because the earlier we start, the better it is, right? The more we can learn. Awesome. For those whom it is black screen, just try to refresh. Otherwise, others can hear and see me properly, so it seems all good. Yep. Yes. Awesome. So I saw the form that you guys have filled, and most of you seem to be very beginners, right? So I'll take the classes accordingly. We will start with like beginner level, and we will try to cover as much as possible. But for those who already know system design, initially they might find it a bit slow because we are going to start from beginner level. What is going to happen is that you might find initially it a bit slow, but you will cover basics so properly. It will be such a good revision for you that after this, you will never need to worry about system design at all. Okay, so we'll get ready for interviews. We'll understand system design properly, not just for interviews, but like that also, right? For those who are facing issues, just try to refresh because most of the people are able to see and hear properly. So it seems to be working fine. Just refresh and we'll get started. I will be going through the chat, so I'll be able to see properly. Yes, there will be a 10-second, like maximum 10 seconds lag, but I will be able to see your chat. Don't worry, because it's like live for so many people. So there might be a bit of lag, but that's fine. Just refresh it, guys, just refresh. This is live, there's like a 5-10 second lag, that's it. Yep, awesome. Can we get started? Blank screen, guys, just refresh and switch to high quality data server. You should be able to see, make sure that your internet connection is good. You can watch either from phone or from the site. Okay. Awesome. I'm starting now. Wanted to just say that, see, for system design, I need you guys to be very patient because we're going to start from basics. And in the starting, it might seem like, why are we studying this? This is like, what we did not want to study in college. But trust me, like the more we will study, the more it will hit you that you're able to design the entire system, and it was completely worth it. So I need you to be completely patient with me and to, just show up with patience, dedication, have trust in me that after this, you will never have to worry about system design. So I need you to have that trust. Yep. Guys, for most of the people, it is visible and audible. So check your internet connection and try to refresh. It should be able to work. Just try it out. Yeah. Can we get started? Sorry, like just give it 5 minutes for people to get used to the new server and for them to get used to the new thing. We'll get started quickly. From tomorrow, we will not have this time, this wait at all. We'll quickly get to the discussions. Yep. Right now, obviously, it is live. You can play only at 1x, but once the recording is available, you can fasten it. You can watch at any speed, right? So it will be great for you for revision as well. Okay, awesome. We're getting started. Quickly, who will tell me what is high-level system design? Why are we reading? Why are we studying high-level system design? Why do you think all the good companies like from Google, Amazon, Netflix, every single company has a dedicated round for system design, and it is so important. And nowadays, like earlier system design used to be asked for people with say 3-4 years of experience. Now system design is asked even for like 1 year of experience. Why do you think system design is being given so much importance? And why is it so hard for people to read it and to study it? Why do people find it so hard? Okay guys, setup discussions are over. People are able to join. If not, just refresh. Otherwise from Chrome, just try it. Okay. Now what I want you to do is tell me about system design. Let's get started with the discussion about system design. Let's get started with studying. Yes? Awesome. So Naveen is saying reliably read and write data at scale. Cool. Okay. There is no wrong and right answer in system design. It is so hard, correct? People find it difficult. That's why big companies asking all about it. Yes, it is hard because you need to know a lot about it. It's like a huge ocean of things. We need to know networking. We need to know databases. So what we'll do in the course is we'll also cover the common databases that are used by the companies. What are the trends? What are the different things? Like you must hear a lot of tech, right? So like you might hear WebRTC, you might hear Cassandra, you might hear SQL, NoSQL. Like what is it? Where to use what? We will discuss pros, cons, trade-offs of everything, and I will actually show you demos as well. Okay? Okay. So today's first topic that we had actually seen was client-server architecture, and we will get started with client-server architecture. I hope you can see my screen and you're able to see me writing client-server architecture over here. Yes? Can we get started? And I want one of you to quickly tell me what is client-server architecture, what is a client, what is a server. If you can tell me this, then we'll just move ahead. In a very, very simple language, what is a client, what is a server, why do we even talk about client-server architecture? Yes, guys, demos will be covered, everything will be covered, don't worry, focus, we are getting started. Everyone, show me the excitement, we are getting started. Yes? So, come on, what is client-server architecture, what is client, what is server? Right, so Naveen is saying, Tanuj is saying client which makes the request, server which provides the service. So a very, very simple definition, this is what everyone will tell you, that it is based on request response architecture. Right, so basically client is the one who sends the request and server is the one who is going to fulfill the request, right, and it's going to send the response. So request is going to go like this and then response is going to be sent. So this is request, this is response. Now I have a question for you. Firstly, can you think of any good examples of request response? Like what are the good examples of client-server architecture? Browser-side data center where code and response. Okay. Making request and server provides response. Very good. Server like a waiter in restaurant, yes. Push and pull, yes. So basically, suppose we are browsing on Netflix, we are trying to just, suppose you browsed Kirti Barswani courses and came right now, right? So you were the client and the server somewhere was the server. So client server. So basically you sent a request that I want to see a particular site or I want to browse Netflix, and then the server responded, correct? So this is client server architecture. Now my next question for you is that do you think ever that an application server, like you must have all heard of application servers, right? When we try to make Uber or Netflix or something, there is a server out there. Do you think that that server can actually be a client? Or do you think that server is always a server? Okay, let me repeat that question and think about it and answer. Okay, no faltuka discussions happening now. Try to focus on this. Okay, I want to ask you that can my application server ever act as a client? Like, doesn't make sense because it is a server, right? Can it ever act as a client? Very good. Siranpreet is saying that it is relative. Very, very good. So basically, client server, the terms itself is basically very relative term and it depends on context. Let's think of an example. Can you give me some good example? For example, so we are sitting over here. This is us. Okay. So this is us. There is an app server. Suppose we are at Netflix or Kirti Barswani courses something. And now we have a database, right? Now what's going to happen is we send a request to our app server that do something, get me the site or something. And there is some information that is kept on database. Now this app server is going to send the request to the DB. So when I send the request to app server, I was the client and the app server was the server. But when app server sent the request to the database, this was the client and this was the server, right? DB server became the server and this was the client. So it's a relative term. It depends on the context that we are talking. Does everyone understand this? So this is like very, very important concept. Client-server architecture, everyone simply understands that, okay, client sends request, server response. But we need to understand that it is a relative thing. It is not like everything that is there on cloud is a server. That is not the case, right? So your app server can also act as client for say DB servers or any other servers. Cool. For those who are facing issues, this is the first day, give it some time. It's fine, just try to refresh. Otherwise, I'll get it sorted. Everything I'll get it sorted today. The recording will also be available. Try to focus now on the discussion. Okay? Is client-server architecture clear? Can we move ahead? Yes? Great. Awesome. So 10 minutes into the course and you already know about client-server architecture basics and you understand that your app server can also act as a client. It is a relative thing. Cool? Okay. Now what we are going to do is, we are going to talk about a lot of networking. Why are we reading about networking? Let's talk in terms of system interview, in terms of system design interviews. So what happens in system design interviews? Okay, I can see that you can't see this. One second. Networking, can you see it now? Yep, okay. So why do we need to know networking? Now in interviews, we will design a lot of systems, right? Suppose we're designing Amazon or Netflix. We know there are a lot of components. Like in the curriculum itself, you must have seen that we are going to read about a lot of things. There's load balancers, there's proxies, there is cache, there is databases, there's so much, right? But when we actually start designing our systems, the first question that comes, like a lot of time, that how is the communication going to happen between these components? Now, these could be any components. It could be servers, it could be cache, it could be like literally any component of the system that we are going to design. But we need to understand that how communication is going to happen between these components, right? For that, we need to understand the basics of networking. Otherwise, when you are being asked this question, you will not be able to answer it. So networking might seem like very theoretical thing right now, but what is going to happen is it is going to be extremely helpful, because I will tell you the exact questions that are asked in interviews, and especially in daily work also you'll be able to identify that you were not able to understand like few topics because they were networking related. A lot of you are from non-sales background, so you should be able to understand them. Now see, networking is a very, very huge topic. It's huge, right? We have to understand so many things in networking. So what we are going to do is we're going to understand only the things that we need to know for system design. We don't need to know all the detailings about how things are working, like at all the levels, right? So I'm going to tell you that how much you need to know for interviews, how much you need to know, like a good to know thing for say system design in general to learn. And then we will see that how much, like where to draw the line and where to start, okay? Some of you still feel facing black screen. So my team is taking this up parallelly. They will be looking into it. Don't worry. Try to refresh. Try to join from like different, probably from Chrome or from your mobile itself. You can join and you will be able to see. Okay. Log out or log in. It will be clear. Okay. Awesome. So now what I talked about, that why we need to understand networking. Yes. Now what we are going to do is, we are going to understand that how much we need to know about networking. See, how the data is going to flow between any two components seems like a very, very complex topic, right? That how the data is going to go from every component to every component. So what, as smart people, what we have done is that we have divided this entire very complex networking task into smaller modular components. So what we are going to do is, we are going to make this entire tough structure into smaller, simpler things, and we are going to try to understand in a simple way. So you all must have heard of layers, like there's something called OSI model, and there's something called TCP/IP model. You must have heard of it, right? If you are a CS student, you must have heard of it. Or if you have ever tried studying networking, these are like the first things that you hear about it. So basically what we have done is that because networking is so complex, we have divided into some layers, okay? And we have come up with a hierarchical structure. Now why a hierarchical structure? This is just to make you understand that what is happening. So basically, when we divide it into layers, what we are doing is that at every layer, so these like the upper layers, the higher layers, take care of the application level. So basically, our web browsers like Chrome, Mozilla Firefox, and all of these, like how the communication is going to happen there. Then lower level is basically that we are taking care of how the bits are basically being transmitted, physically how the transmission is happening, say through wires and all of that. So there is one lower level, there is one higher level. Now OSI model, what it has done is it has divided the entire structure into 7 layers. This has divided into 4 layers. But these are just conceptual frameworks. For system design, you don't need to know exactly what layers are there or how things are going to happen, because it's the same thing that's going to happen. Okay, it's the same thing that's going to happen. Basically, every layer is going to use the info from the downward layer. It is going to help the upper layer. So if there are 4 layers, at every level, the layer is going to take the help from the lower level. The lower level functions are closer to the physical transmission of data, and then the upper levels are going to use this help, and then they are going to help us with the application level. Okay, so that is why a hierarchical structure. Now you don't need to understand the layers properly, you don't need to know all the details, but for system design, there are 2 things that you do need to know. Okay, you cannot miss this. This is extremely important for you. And like the first extremely important point that you need to know in system design course is this, that there is something called transport layer. And can you guess that what is the second layer that is very important? Can you guess? What is the, so there are many layers. I said there is OSI, there is TCP IP. Now I want you to tell me that in terms of system design, what are the 2 very important layers? Very good, Rohit. So there is one transport layer and there is application layer. And we need to understand in detail for system design. So this is going to be our focus for today and if needed tomorrow. Okay, we need to understand these 2 layers properly, need to understand that how transmission is happening. Okay, awesome. Now let's first understand what is a transport layer, what is an application layer. In a transport layer, basically we are talking about data delivery, that how data is being transmitted. Yes, that what we are going to do is, because the data is going to be huge, right? There is going to be like huge file, or say there is a video or there's an image. Because the video is huge, we need to divide it into small parts. So what we are going to do over here is we are going to break it down to small segments, and we are going to see that how it is being transmitted over network. See, the name itself is very clear, right? Transport layer protocol. We are going to learn the transport layer. So basically we are going to talk about transmission, that how the transport of the data is happening. So transport layer. Yes. Application layer is basically the topmost layer. We talked about the layering, right? That there are some lower layers, there are some higher level layers, there are some topmost layers, right? So here I talked about application level, right? So application layer is actually the topmost layer in the networking stack. It is the topmost layer. And it provides services and protocols for, like say, web browsers, web servers, for all of this. Okay, everyone with me? Are you able to understand this much? So again, let me repeat that. See, networking is very complex. We are going to make it very simple, divide into layers, and like there's a hierarchical structure. We are trying to understand how the data is being transmitted, because this will be a question that will be asked in an interview, that how the data transmission is happening. Now, since there are many layers, we don't need to know about all of them. We care only about 2 layers, that how exact data is getting transmitted, that is transport layer, and how our apps are handling it, or basically application layer stuff. Yes, so 2 things. Can I move ahead? Now, in every layer, there are some protocols that we follow. What are protocols? Some rules that we need to follow, that is how the transmission is going to happen. What is transmission? It is basically communication between 2 communicators or processes, right? Now, if I am talking to you, you need to be able to understand my language. Very simple stuff, right? So, sorry about that. So basically, for every layer, we need to understand that how the transmission is going to happen, and that is called protocols. So every layer has its own protocols, right? We are not going to cover data link network layers. These two are the most important ones, and you will understand that why these two are enough for system design. Just stay with me, okay? For transport layer, what can you tell me protocols for transport layer and application layer that are very, very important? What might be the protocols that are important for transport layer, and what might be the protocols that are important for application layer? Can anyone tell me that, okay, these are the ones that are famous? So again, quick revision: transport takes care of data delivery. We divide it into small segments. We make sure that the data is transmitted over network, right? Application layer is like the topmost level. So there we are going to talk about web browsers, web servers. Very good for those who replied. So transport layer, the two important things that we are going to focus on is TCP UDP. And it is an extremely important topic that you cannot miss for system design. Many questions can be around TCP UDP. Any components that you will make, you will be asked why TCP over here, why UDP over here. So now next that I'm going to do, forget everything else for next some amount of time. We need to focus on TCP UDP. Yes, everyone with me? Now let's try to talk among ourselves and let's try to understand that suppose we were trying to come up with a transport layer where we are supposed to send some data, right? We are supposed to send data. Now, how do you think you would actually design it? Now, there are multiple ways in which you could have designed it, right? One way I think would be that I just want the data to reach from, say, point A to point B. I want it to reach it with as much speed as possible, because what am I doing? I'm say doing live streaming like this, or I am playing an online game. I want the data to reach with a lot of speed. Okay. Second way of this would have been that I want my data to be very safe, secured. Basically, I want a reliable way to reach over there, right? Basically, when I send any data, it should reach over there properly. If there's some error that occurs, then also it should reach. Like for example, networking system, right? It is huge. There are wires everywhere. We could lose some data in between when the communication is happening. But we need to make sure that some data always reaches. Like for example, if we are making banking systems, or if we are say sending emails, we do not want our data to be lost. Correct? So there are two sort of things that we need to do when we are trying to transmit our data. Everyone agrees with me? So when our focus is on transmission, when we want to make sure that our transmission is reliable, that it is good, when I want to control our transmission, I am going to use what protocol? I am going to use TCP, Transmission Control Protocol. As the name suggests, you need to understand from the name itself that what am I trying to do? I am trying to control how the transmission is happening, right? I need to make sure that my data reaches there safely. I don't want any data to be lost. It should be reliable. I should be able to control it. Everyone with me? So TCP. Another way, sometimes we do not want it to be reliable, right? We do not want it to be reliable. All I care about is speed. Like video streaming, online gaming. Suppose you're playing an online game. It is okay if your 1 or 2 clicks are lost somewhere, right? Because in the end, you should be able to go from point A to point B very fast. Streaming should happen. You should be able to hear me. It's okay if there's like some milliseconds lag. It's fine, right? So that what I do, what is my focus over there? Can anyone tell me what is the protocol that I'm talking about? My focus is only on the data, right? So user datagram protocol. So UDP. Yep. UDP, TCP, our main focus. Very good, guys. Now we are going to understand this in detail. A lot of questions in system design is going to be based on this. So you need to understand. You will be given a system and you will be asked which transport layer protocol would you use. Now I am asking you these questions and you need to be able to tell me. Suppose I have to send a mail, right? Then I need my data to be reliable. Then what will I use? I will use TCP. If I need online streaming, if I just worry about speed, I don't worry about anything else. I don't worry about my data being lost or anything. I am going to use UDP. Yep. Now see, the thing, now I am saying that the speed will be more, but just think about it logically, that when you take care that there is no data being lost, you are basically checking for errors, you are making sure that it goes in the correct order. Obviously, there's going to be an overhead, right? If you were designing this protocol, if you were working on making sure that there is no, like, there is no error, the order is fulfilled, everything, obviously there would be some extra computation that you would need, correct? So because you need some computation, exactly, it is a trade-off. So because you need some extra computation, the speed will be slower than UDP. Because here you are not doing any extra computation in UDP, obviously it is faster. It doesn't care about anything else. It doesn't care about ordering, nothing. Just send the data, just make it reach as soon as possible. Obviously the speed is going to be good, correct? In system design, in every single place where we, like every single topic that we here like study from now, we will talk about trade-offs. We will talk about what happens when we use this versus that. So at every point you need to understand the pros and cons of using a particular concept. So here you need to understand that if you give speed the priority, you will be trading off what? You will be trading off your order, your control over the transmission. Your data might get lost, there is no reliability, there is no guarantee that it is going to reach. Versus in TCP, if you want that guarantee, then what will you trade off? You will trade off speed. Yep. Very good. Connectionless, connection oriented, Deepa is saying this. So these are the terms, these are the hi-fi terms that we hear. Connectionless versus connection oriented. And now because you've understood the base that okay, when to use TCP, when to use UDP, so that you don't forget it at all. What we are going to do is now understand in detail that how TCP works, how UDP works, and then we will compare. Okay. So let's first try to understand how TCP works. Everyone with me, guys? Half an hour into the class? Yep. Yes, everyone understanding why we need to what all we did till now? Client-server architecture basics, we talked about why we need to understand networking, then we talked about different layers, then we talked about the layers that we need to know, that is transport layer protocol, that is transport layer and application layer. Then we started talking about transport layer. Now what we are doing is we are talking about protocols that are needed for transport layer. Yes, so we are starting from TCP. Awesome. Let's understand how TCP works. Now suppose let's try to see that if we were supposed to come up with TCP, what would we do? What is our point over here? We want to design a very, very reliable transmission protocol, right? So basically we want to be sure that data should reach from one place to another, right? So everyone says that someone used the term connection oriented. So TCP is actually connection oriented. Why does that happen? So if there is a client and there is a server, basically sender and receiver, what is first done is a connection is established. Then the data transmission happens and then the connection is terminated. So there are three things that happen in TCP. Now, this is something that you don't need to know for interviews, but this will be a very good to know information, and your system design, basics will be completely clear after this. What you need to know for interviews is TCP versus UDP, which we'll do in detail more. What we are doing now is you need to understand that how TCP works so that you're able to tell everything. As some of you are already saying, we need to talk about how the connection is made, how the transmission happens, and then how the connection breaks, terminated. Correct? So let's get started first with how the connection is made. So for that, give me 1 sec, guys. Give me 1 sec. Give me 1 sec, I'll be back. Okay, I'm sorry about that. Yeah. So let's try to understand how TCP connection is established first. Now we talk about three-way handshake for that, right? Three-way TCP handshake. Now what is that? Let's try to understand if we are talking over call, what happens? If you and I are talking over call, I will call you, I will say hello. Then what you would do? You would say that, yeah, okay, hi Kirti. is it you, Kirti? Like I heard hello, but is it you? Then I would say, yeah, it's me, right? So basically, I have called you. This is me, and this is you. So I call. You guys can hear and see me, right? Properly? Yep. So I called you. I said a hello. You said, hi, is this Kirti? And then what I said? Yes, hi, I am Kirti. So now the connection is established. Now what we are going to do? We are going to start talking over call. Yes, this is how we do on phone. Yes, that's what we do on mobile. So similar thing is going to happen over here also. What we are going to do is that there is our sender and there is a receiver. So there is a sender, there is a receiver. So basically what our sender is doing is, it is sending some packet. What is packet? It is just some data, basically bits, put in some way, because receiver knows that we are going to talk in TCP. It knows that this is this kind of packet. So what it is going to do is, it is going to say a SYN packet. Basically that, it is saying that I want to establish a connection. Can you please establish connection with me? So now what sender is going to do is, sender is going to say that, okay, I acknowledge that you want to put the connection with me. So it's saying, yeah, hi, is this Kirti, right? And then what we are going to say is, we're going to acknowledge that, yes, it is Kirti. Can we start talking now? So now when these three things happen, what happens? Our connection is established. Yes, and this thing is called a three-way handshake. You will hear this a lot when it comes to TCP. Now I hope you will never get confused. I hope the concept is clear. Okay, now I hope you are able to see properly. So what we do, the sender first tells the receiver, I want to establish the connection. Can you please talk to me? What sender is going to do, it is going to say that, I am acknowledging your request and I am okay. So now again sender will say that, okay, I'm confirming, and now now connection established, we can start talking. Okay, so this is how connection is established. Yep. Now since the connection is established, okay, I am just, yes, SYN means synchronize. So we are just trying to synchronize that, okay, I am trying to connect. ACK is acknowledge. So I'm acknowledging that you want to connect with me. Then I acknowledge and then I actually connect. Yes, so SYN, ACK and ACK. Cool. It is just, basically you don't need to know these details for system design. What you need to understand that there is a three-way handshake happening, because of which the connection is built. The connection is established. Okay? Yes, I will try to make sure that my face doesn't hide it. Okay? Cool. First, so sender is making the request. It is request response, right? So sender is the first person who is making the request. Then receiver response, then again sender response again. So sender to receiver, receiver to sender, sender to receiver. Final ACK means finally acknowledge that, you send me a SYN ACK. So basically we say that, yes, hi, I am Kirti. I have acknowledged that, you are the one who's talking. Now we are going to, this is our connection establishment. Now we are going to start talking. Okay? How will the speaker know who are its receivers? So in the packet, there will be some information that there will be IP, port, all of that will be there. We will go into the details later. Yep. So in the packet itself, all of that is there, that where am I supposed to go. So that's how the transmission is happening. Now that the connection is established, what we need to do, we need to make sure that the data transfer happens properly. Why did we do so much of mehnat and why did we set up the connection? Because we want to make sure that our data transfer is very, very reliable. So what we are going to try to do now, we are going to make sure that reliable data transfer happens. Yes. So, Syed is asking, are we going to get into details of header checksum? No, that is not needed. Okay. Four-way handshake we have not discussed yet. Don't ask questions about something that we have not discussed, because that might confuse others. Try to focus on what I am teaching and try to ask questions that are relevant to what I am teaching currently. And then after the class, you can ask about extra things about, will we do this? Will we do that? Like that. Okay. someone has not understood, so I'm quickly repeating it. Right now in TCP, what we are trying to do, we are trying to establish the connection. First we said hello, so basically the sender is saying that I want to establish the connection. Then our receiver says that okay, you want to establish the connection and I'm acknowledging that. Then sender sends back and says acknowledged. Now okay, I'm going to start. The connection is established, now I'm going to start the data transfer. Okay. Yes, all of this is happening at transport layer. We are talking about TCP, which is a transport layer protocol, transmission control layer protocol. Cool? Okay. Now what we are going to do is, okay, what is reliable data transfer? Now someone asked that what is reliable? Basically making sure that no data is lost. So even if like you sent something and some data got lost in between, you're going to resend it. Or say some error occurred, then you're going to make sure that it is either resent or ordering is confirmed. Like suppose you're sending long data, which suppose you have to divide it into 100 parts and send it. So first one will be sent, then second one, then third one, and so on. So you have to make sure that your order is also maintained. So ordering is maintained, there is no error, all of that, that means reliable data transfer, right? As I said that our data might be huge and we need to divide it into small parts. So what happens inside this? Segmentation. It is very simple. If you think from that name itself, you will be able to understand. What is segmentation? We are dividing our data to segments. So segmentation. What is the next thing that we do? We take care of transmission. Okay. And see, so basically, I am again saying reliable. We have to make sure that it reaches. But when our sender is basically sending the data to the receiver, how do we make sure that the data was sent properly? So that we don't know, it might get lost in between. So for that, obviously, our receiver has to acknowledge. So for every single segment that you send, there has to be an acknowledgement from the receiver that yes, I have received it. Only then you are very sure that your data was not lost somewhere, correct? It is received properly. But now the problem is that imagine your data is huge. You have divided your data into many chunks. Suppose hundreds of chunks. Now for every single chunk that you send, every single segment that you send, you're going to send yes, acknowledge. Just imagine the amount of server load that is going to be there. For every data that is being sent from the sender to receiver, our receiver is saying yes, acknowledge. Isn't it like very, like, isn't it going to be like a lot of load on us for no reason? Yes. So what usually happens is that sender and receiver together, what they do is something, if you know a bit of DSA, then you might know a window sliding technique. It is similar to that. So basically, if you don't know, it's fine, I'm going to explain it. Basically, we talk about a window or about like after these number of packets, you acknowledge and you tell me that you have received or not. Don't tell me after every segment, don't tell me after every packet. Tell me after some segments. Yes? So that is what we are doing. We are being smart. And then if acknowledgement for this window doesn't come, you're going to resend it. Yes? So this is called flow control. So you're controlling the flow also. Yes? So sender and receiver usually they decide the window size and then they decided okay when the acknowledgement is going to happen. Yep. Awesome. So we talked about how the connection is established. Then we talked about how the transmission happens, right? Now what we are going to talk about is how the connection is what? How it is terminated. Very good, right? So now what we are going to do is, see, just think about it. You are talking to a person, you build the connection, you send some data to that person. Now, sometimes some problem might happen, like there is no response or something like that. So some abrupt connection termination might happen. That is there. We are not talking about that. What we are talking about? We are talking about that how a graceful connection termination is going to happen. A graceful connection termination. Basically, how are we going to make sure that, now we are going to stop a connection. Okay, some people are asking to explain flow control again. See, it is a good to know information. It is not necessary, but still just explaining it. So basically, we need to make sure that data reaches the receiver, right? So what receiver does is receiver acknowledges that yes, I have received the data. Yes, I have received the data. But sending that acknowledgement literally after every segment is obviously very costly, correct? So what they do is that after a window of segments, basically after a few segments, you send me the acknowledgement. Don't send me for every single segment. That's it. That's all we are doing. Yes? Clear? So that's called flow control. So I'm controlling the flow, that okay, how the data is being sent or how frequently I'm going to get the acknowledgement, all of that. Yes? Okay. Now we are going to talk about the termination. Okay, quick revision. We are at the transport layer. We are talking about TCP versus UDP. But for that, we need to understand properly how TCP works. So our focus right now is to understand how TCP works. We have talked about how the connection is built, how the data transfer happens, and now we are going to focus on how the termination happens. When are we going to stop sending the data? Yep. Okay, I want all of you to keep chatting with me. I can see only 2-3 people commenting. I want all of you to be active because this is so much of theory and you might get bored in between, right? So I want you to keep messaging me, plus try to answer each other's questions also. Yes? Yes, you will get the notes after the class, don't worry. Okay, cool. So what we are going to do is talk about the release. So now see what happens. My question to you is that there was a sender and there was a receiver. So it was a request response. So a sender told that I want to establish the connection. But now when we are terminating, this is a very important point that you need to understand, that the connection can be terminated from any of the sides. It could be either terminated from the client side or from the server side, from the sender or from the receiver. So it is not necessary that only client or only server is going to do the termination. It is very important point. So anyone can terminate the connection. You need to understand that, right? So what we are going to do now is we are going to call one as initiator and we are going to call one as receiver. Because now this initiator could have been a client or server. Anyone could have tried to terminate the request, right? But we need to call it something, right? So we are calling it initiator. Cool. So now what is going to happen is, again these two are there. Again initiator needs to tell the receiver that I want to finish the connection, I want to stop, I want to terminate. So it sends a fin packet, basically again some data being sent by which receiver comes to know that I need to finish or I need to close this. And as soon as it receives, what it says that okay, acknowledged. You want to do what? You want to finish the connection. And as soon as it acknowledges it, it starts performing something. It needs to perform its own actions. It needs to, terminate its own processes. And once it does that, it says that, okay, now I have stopped my processes. I am also ready to finish. I am also ready. Then what happens? Now this person acknowledges, okay, you are ready. I am also getting ready. I am also ready, acknowledged. Now what happens? Both of them get into a time wait state. What is that? So basically if there are some packets in between that were yet to be sent, they will wait for some seconds that okay, now all the data is being sent, both are ready to terminate, let's terminate. Now what will happen? Closed. So here what is happening? 4 times, right? Send data, send. So this is called what? This is called 4-way handshake. Okay. Again, guys, for system design interviews, you need to understand TCP versus UDP. When would you use TCP? When would you use UDP? And we will discuss that into detail now. But what we discussed now is good for system design. You need to understand how TCP works, so that if anyone asks you that how TCP works, you should be able to explain. When someone tells you that it is a connection-oriented protocol, you should be able to understand why it is a connection-oriented protocol. Basically, what are we doing? We first establish a connection, then we transfer the data over that connection, and then we terminate the connection, right? The 4-way and 3-way difference, let me quickly explain. Here what we were doing, the sender was saying SYN, it was acknowledging, and then it was acknowledging, then going. 4-way what we are doing is, we are sending a FIN packet, it is acknowledging, but then it needs some time to close its own processes, right? So for that, it is sending again the fin that, okay, now I am ready to finish. First, it just acknowledged, and this happens immediately. This acknowledgement, this happens immediately. Like, right? Yes. So it is like a bye over a phone call. So this is saying that, okay, I want to cut. And this is saying, okay, you want to cut, but wait, I want to do something before you cut, because I want to finish some processing or maybe something. Okay, then it is saying that, okay, now I'm done, I want to finish. And then this guy acknowledges. Cool? Yes? Cool. Now what we are going to do is we are going to move to the TCP UDP differences. Let's try to understand in detail that how TCP UDP, like what is the differences. And this, my friend, is the most important point that you need to understand for system design. You cannot miss it. In terms of interviews also, you need to understand TCP versus UDP. Okay, you need to understand this. ACK means acknowledge, so that means it is acknowledging immediately. It is saying that I received I received a request, acknowledged. Okay, cool. Now let's try to understand the differences between TCP UDP. Whatever differences you can think of, you can let me know in the comments. I am reading the comments also. Okay. First thing that we read about, that TCP is a connection oriented protocol. Connection oriented protocol connection, right? Connection oriented protocol, let's just write that much, right? Versus UDP is what? It is connectionless. So basically there is no connection that is established. It is faster. You don't need to do the three-way handshake. Yes? Cool? Okay. Now what happens is, in TCP, devices should establish the connection before transmitting data and close after that, versus in UDP there is a overhead of establishing connection. Because there is no overhead over here, right? There is no overhead, say for establishing, for maintaining, and for terminating. For all the three things that we had to do in TCP. We don't have to do any of that in UDP, right? So because we are doing so much in TCP, it is reliable. What does reliable mean? We know that it is going to guarantee spelling is wrong, guarantee delivery of data. But UDP is what? It is unreliable. That means the delivery is not guaranteed. Guys, it is very, very important to understand these differences. You will have to make your system design decisions on the basis of this. So please try to concentrate and try to understand these. Okay. I know you can't read, so I've just scrolled up. Yeah. Now here what we are doing is, because we have to make sure that everything goes properly, here there is extensive error checking mechanism. Error checking happens very extensively. Okay, I am just stopping my video, or just I'm making myself smaller for the time being so that you are able to see properly. Okay, here what happens, there are basic error checking. So basically, even if there is some problem, it is fine. You just transmit the data properly. That's all that I care about, right? Here in TCP, sequencing or ordering is done. So basically what you are doing, you are making sure that your data reaches in a particular order, right? Here there is no sequencing done. So what you have to do is that you manage it at the app layer, or basically you do it yourself, or you can write something on top of UDP to do the sequencing. So basically anything about that we care about the quality, that is in TCP, versus speed is in UDP, right? Because there is overhead, because we are doing error checking, we are doing so much, obviously what happens, this becomes slower, right? And this becomes faster. Correct? Yes? Now what happens, because we are doing error checking, here there is also retransmission that I was saying. That if you lose some data, you are going to make sure that you are going to transmit it again. So there is retransmission of lost packets. Versus here what happens? No retransmission. Guys, You don't need to actually write everything down also, because I'm going to give you the notes. I'm just doing this for discussion. So it is fine if you are not able to note down everything with me, but you should be able to understand what I'm saying. If you're not able to understand, you can ask me. Okay. So because we are doing so much in TCP, everything we are doing, so obviously it is safe, it is trustworthy. This is not safe. I hope by now everyone has understood that what it is just quick. It is not safe, it is not trustworthy. Okay. Can you give me examples of where you would use TCP, where you would use UDP? Yeah, can you give me examples? So TCP, when you want to make sure that everything reaches properly, email, right? Military services, or say surfing, or when you're sending your data. Over here, what is the thing? Here, maybe say game streaming, or say video music streaming, right? Okay, I'm just going through, go through the chat now and see more of questions that you guys have, right? Does Netflix Prime uses UTP for video streaming? We will discuss all of that. But see, if someone is giving you to design a system, what you need to do, you need to ask that for you, what is important? Is speed more important than UDP? Is your reliability, is your error checking, is your sequencing more important? Then I'm going to use TCP. And you must have seen the same discussion happening in the system design videos on my channel. You must have seen similar kind of discussions happening, right? So okay, one thing that is there in UDP that is not there in TCP, that I would like to tell you, that in UDP, because it is faster video streaming, like suppose we are doing we are streaming a game, suppose say FIFA or cricket match, and we want to send it to many people, not just one channel, but we want to send it to many channels. Then we can do that, because basically what it is called broadcasting. So broadcasting is also supported. Versus over here, broadcasting is not supported. So basically, if you have to send to one channel, you would have to establish the connection, then send it. Then again to send to another channel, you would again have to establish the connection and then send it. Cool? Yes. How UDP is connectionless, there is no connection being established, right? You can just send the request. So basically, you just give that I want to go to this port. You can just go like, okay, there is one. So you could send it to like this, then response or response. You could just send. There's no connection that is being established. Okay. So, yep. Now, can I move ahead? Yep. Cool. Can I move ahead, guys? TCP, UDP, everyone clear? Very important for system design. You just cannot miss it. One very interesting question that I would like to ask you. I don't know how many of you have heard of DNS. Basically, what happens in DNS is that we give an IP. Now, we give a host name that, okay, suppose Kirti Purswani courses or Netflix.com, right? And corresponding to that, DNS gets us the IP, right? Now, according to you, should DNS use TCP or should it use UDP? According to you, just think about it. So DNS, what does it do? We give it the host name, it gives us the IP. Now you need to understand that. Now you need to tell me that whether it uses TCP or UDP. It is actually an interesting point. Yes, domain name system. So some of you are saying UDP, some of you are saying TCP. See, what happens is that DNS actually uses UDP. Even though that for DNS, reliability is very important because it is giving you back the IP. So why does it use UDP? What is the point? Because what happens is DNS is such a common thing, right? It is a very important feature. And what happens is that because it has so much of traffic, the speed is of very much importance. Like it's of very high importance, speed. Now what happens is, because you want to give speed the preference, and also there's a fact that your DNS query or whatever you want to send, the requests are so small that it fits in one packet itself, in one segment, in one UDP segment, because the request is so small. Now what DNS does is that because the packet is so small, it sends it in UDP and it waits for the response. But suppose that if the response is of the size that is bigger than one packet, then ordering is not going to happen and all of that is not going to happen. Then it is going to switch from UDP to TCP. If the request becomes too big or the response becomes too big, then it switches. But because there is so much of traffic, because the speed is such a huge priority over there, it ends up sending with UDP because it knows that your request is very small, it can fit in one packet. But only so it is fully reliable. Arjit is asking DNS is not fully reliable. It is reliable, but what happens initially is UDP. But if something gets lost, it will send TCP and it will make sure that you get the data. Right? So this is something interesting. So I just wanted to tell you. But overall, in interviews, in discussions, when someone asks you that TCP versus UDP, now you know the answer. Correct? I am going to pause for 1 minute and I am going to wait for your questions and I am going to answer all your questions before we move ahead. Okay. Okay, someone is saying repeat power cut for 50 minutes. Guys, I cannot do that. You could have just joined from mobile data or something. But if you are not able to join from mobile data also, you can obviously watch the recording. Recording is going to be available. I obviously cannot record these, tell you the entire same thing, right? 300 students over here. Okay. Please don't send such messages on the chat because I have to make sure that I answer the relevant questions, the doubts, right? Okay. What if I want both security and speed? See, Prem, you cannot have both. You obviously have to have some trade-offs. And interestingly, there have been, like Google has come up with something that is over UDP, which is called QUIC. We are going to cover this now. So basically, they came up with something that is better than TCP and UDP. It has come up with Google, like Google came up with it, and we are going to discuss it in some time. So if you want both, probably you could go into that. But yes. Can you explain broadcasting again? So broadcasting, basically what happens if you want to send data to multiple people together, if you want to broadcast it, just as the name suggests, in WhatsApp, what you do when you do broadcasting, you're sending the data to multiple people, right? Suppose you're live streaming a match and you want to send the data or you want to live stream the match to multiple channels. What you're doing? You're broadcasting your data. Yep. Can we mix TCP UDP? Yes, Google has done it. It has basically not mixed TCP UDP. These are different protocols. These are transport layer protocols. So what you could do is you could build something over TCP or UDP and use characteristics of that and build something over on top of that. Okay, cool. Okay, I'm going to move ahead now, guys. Now what we are going to do is, so we discussed about transport layer protocol, right? Do you remember what were the two protocols that I said were very important for us? One was transport layer protocol. The other one is what? It is application layer protocol, right? Now application layer protocols, can you guys think of any examples? Because there are so many application layer protocols. There are just so many. Okay, give me examples. Come on. Kush is asking me about WebSockets. Guys, don't ask me about concepts that I have not covered yet. Give me some time to reach the concepts, then you can ask me questions related to that. Right now, if you have any questions related to TCP UDP, you could have asked me that. Okay. Application layer. Okay, what did I say? What does application layer do? So it is the topmost layer. So basically, web browsers, web servers are going to talk in application layer protocols. Now, in transport layer there was TCP UDP. For application layer, basically the most common ones that you must have heard of, HTTP, HTTPS, as most of you are saying. Then there are a bunch of other ones. There is File Transfer Protocol, FTP. Then there is DNS, which is again an application layer protocols. There is SNMP, which is Simple Network Management Protocol. There is SMTP, Simple Mail Transfer Protocol. There is POP, again, Post Office Protocol, RTP, Real Time Transport Protocol. So there's a bunch of things, right? So do you need to know all of them? No, but you need to know the names and what happens a bit. So currently what we are going to do is, yes, SSH is another one, RTMP is another one, yes, very good. So what we are going to do is, our current focus is going to be obviously on HTTP, HTTPS, which are the most important ones. And after this, like probably, because I think networking might overwhelm you if I cover everything right now. So we are going to focus on these two, and then we are going to try picking up these as well. Cool? Yep, sounds good. TCP UDP clear? Differences between TCP UDP clear? Very, very important, guys. Now, any of you want to show off what did you learn in the first class? It is TCP versus UDP, because it's a question that is going to be asked in system design. You need to be able to answer it properly, right? Now what we are going to do is, we are going to focus on HTTP. We all learned that application layer protocol is written on top of transport layer protocol, right? So HTTP is written over transport layer protocol. Okay, how many of you think that okay, it is written on TCP, or how many of you think it is written over UDP? Come on, quickly, I want to know that HTTP is written on top of which protocol, because transport layer protocols are what? TCP, UDP, we learned that. Now we are doing what? We are doing application layer protocol, which is what? HTTP. Now HTTP is written above some transport layer protocol. You need to tell me, is it written over TCP or UDP? Now most of you are saying TCP, but interestingly you are not completely correct. All of you are saying TCP, and it is a common question that will be asked, but interestingly you are not correct. So now you can actually show this off to others. Obviously, there are two questions. As soon as I said that TCP is not the correct answer, people started typing UDP. Okay, that is not fair. Let me tell you that what is the correct thing. Let's try to understand how HTTP even came into picture. How did it start? Let's go to our history. This is obviously good to know information, like for system design, nothing that you need to know properly. So first, let's try to see how HTTP requests look. What do you think? Can we try some demo right now? So I guess it will be some sort of change also for you all. Yes? Can you all see the screen? Yes? Okay. So here what I'm trying to do now is, I am going to go to inspect, and I'm going to go into, say, network section. So in system design, in networking, whenever you want to understand what's happening, we can actually understand from the site itself. You don't need to think so much. Let's try to see that what's happening. Okay. When I click on enroll, let's see here, I see one request being sent. Can you all see this? Yeah. Here you can see, so here there's a raw version of the request. Can you see this? This one, request headers raw. So this is an HTTP request. Here you can see that HTTP response. This is a getter. This is a response. Yes? This is the URL where you are sending the request. Now for beginners out here, I want you to focus on a few things. There is a request method. There is a get method. So we need to understand what are the different methods. Why you need to understand all of this? Because when you do, say, system design, like when we do API design after a few classes, you will need to tell that, okay, you are going to use which method, URL, what is the status code that will come. Here you can see something called 200K. We will try to understand what this means. Then here you can see how the request actually looks. Okay, I guess you can see the screen. Give me 1 second. Give me 1 second, guys. One more minute. It is my mistake. Give me 1 minute. By that time, you can keep asking me questions. Okay, there is some problem right now. I will do this demo tomorrow. Is that okay? Does that work for everyone? Yep, sorry about that. Okay, so what we are going to do tomorrow is that I am going to show you that. Okay, I'm sorry about this, but tomorrow I will show you the demo. We will actually see that, okay, what is the HTTP request that is being sent. What you could actually do this. Okay, consider it as a homework. Try to go to kirtiprasanicourses.com. Try to hack my site. Try to inspect it and go to the network section. Try seeing that what happens when you enroll. Can you see any request that is being sent? Okay. Similarly, open say Netflix. When you click on sign up, what is the request that is being sent? Or open Book My Show. Okay. Open. So if someone is asking how to be good at network protocols, this is how we will be good at network protocols. We will actually see that these big common systems, what request are they sending, how are they sending. Okay. So Wireshark, so Wireshark is basically a software through which you can see that what packets are being sent, but you don't need Wireshark also right now. What you could just do is just inspect and see the request that is being sent. I want all of you to try doing it. If you cannot do it, it's fine. I will show it to you tomorrow. Okay. Now let's get back to the history that I was talking about. Let's try to understand that how HTTP even came into picture. Okay, so initially how HTTP was written was that there was very simple. They came up with a version called 0.9. So with every HTTP, if you ever see an HTTP request, you will see something like this HTTP. So 0.9 was the first version that came, and what was there? It was very simple, and there was only get requests. Okay, and we will understand that what does this get request mean, what does these mean. But initially what was there, that we would send some request and response would come in what, in plain text. That's it, in a very plain text. There was no status code, like you must have heard status code 200, 400, 500, all of that, right? You must have heard some fancy things. None of that was there when HTTP came into picture. It was very simple protocol. Text used to come back. Then what happened? HTTP 1.0 came. I am telling you about these because these versions are important. Like HTTP 1.0 came. Now what happened in this? The support for different content was available. Like you could send images, you could send sound files, different things. Then something called headers was introduced, that you're going to send some data in headers. Okay, you're going to send headers and request response. The concept of status code was introduced. Basically, you're going to send a response with status code, say 200, 300, 400, 500, like that. But still, what is the limitation in this? Can you think of any limitation? See, what happens is HTTP is what? It is built over TCP, correct? Right now, over here, all of you were saying. So here HTTP is built over TCP, HTTP is built over TCP. Now, every time a request has to be sent, first the TCP handshake has to happen. Okay, so there's an overhead. So now imagine sending a huge data, and suppose you're sending a video file. Now for every single segment, will you first do a TCP connection? You will do a three-way handshake and then send the data, then send the data, then send the data. So there's a limitation in terms of performance. So performance was not good. Scalability was not good, right? And so basically you could not handle multiple requests properly. You could just handle one request, okay, over a single connection. Now what you had to do was that now came HTTP 1.1, and this is so far the most widely used one, right? So till now HTTP 1.1, and I will show it to you that when you see post request, get request, I was about to show it to you now, but unfortunately that was not possible. So on Netflix, Kirti Prasani Courses, Book My Show, open these sites, and I want you to do this yourself. Actually, I want you to send me screenshots on Discord channel today that you were able to see, and you should be able to see these versions. And you should tell me that you were able to see HTTP 1.1. When you see this, you will be able to tell what? You will be able to see a keep alive header. What does this mean? Because in HTTP 1.1, there was something called persistent connection that was introduced. And again, this is an answer to a very common system design interview question. So basically, if multiple requests have to be handled over a single connection, what you do is basically you make a persistent connection. You send this header as keep alive, and now what you can do is you can keep sending the data. First you do the handshake, the TCP handshake, and then after the TCP handshake, what you can do is you can send multiple data like request response like that, and then you can do the termination. It is not like only one request you are going to send one data. So you can have what? You can have multiple requests over a single connection. What does a connection mean? The connection that we built using the handshake. Make sense? Yes? Cool. Keep alive is basically a header that is sent. I will actually show it to you. I will demo it to you. Okay, and there's a time limit for how long this connection is valid, and there are a lot of things. But then with HTTP 1.1, not just persistent connection, there were a lot of things that were introduced. There was like cache control, there is chunk transfer, encoding. There's a bunch of things that we don't need to know. Okay, Prasad is asking what it means by connection, right? Connection means yes. So there's a dedicated thing. So basically when a connection is established, now over this connection you can send the data. Right, so you know that okay, data will be sent to here only, right? Cool. Okay, so basically, okay, let me repeat that. So initially when HTTP came into picture, it had only GET request. The request used to come back in plain text. There was no status code. Then there was some improvement made. Headers were introduced. There were status codes introduced. But then the problem was, this was the problem. The problem was performance and scalability, right? Then what we did, then we said that okay, we need to make this even better, and this is still the most widely used HTTP version. There is something called persistent connections. Over a single connection, you can send multiple requests. Yes, clear? Cool. Now comes the most interesting part. There is also, okay, before that, there is also HTTP 2. HTTP 2 again has basically better, more, so it has something called multiplexing. You don't need to know the details. Basically a more efficient version of persistent connection. There was also header compression. Basically multiple requests and responses was the major point over here, like that was being worked on. So you just need to know that. Now after HTTP 1.1 and 2, now comes the very interesting point. Now comes the interesting point of what? That, okay, now till here we were using TCP. Here HTTP 1.1 we were using TCP, HTTP 2 we were using TCP. Now came HTTP 3. That uses UDP. Okay, interesting. Most of the people, they will think that they know everything and they will say that HTTP works over TCP, but now you guys are smart. You will say that no, HTTP doesn't always work over TCP. What happens is that in 2020, this HTTP 3 has come. So it is actually fairly new. And the underlying protocol is QUIC. Remember I was talking about this? So actually UDP is the transport layer protocol. On top of this, Google came up with this QUIC. Now what does this QUIC stand for? It stands for actually Quick UDP Internet Connections. So Google came up with this and it is built over TCP, and basically it works like TCP only, but it has added advantage, like there's latency is even less. So you are not waiting for like the connection response to come. Then there is improved congestion. Basically the traffic is controlled properly, the traffic congestion control is there properly, better handling of unreliable networks. So basically what I was telling you initially, that UDP is unreliable, but what we have done is that Google has come up with a system that makes this also reliable. Basically it has come up with a protocol that is written on top of UDP, and it has made sure that okay, now it is handled also properly. Yep. Yes. For those who are asking about gRPC, don't worry about it right now. We will cover it, not right now. It will become very, very overwhelming for beginners. See, there's so much that gets involved. Right now, we need to understand these, okay? Piyush, it is not the browser that sends the HTTP 2 or 3 requests. It is a particular app or a particular site that sends the request, and it depends on how it is implemented. So that is why I told you that today take it as a homework, go home and try to inspect different sites and try to understand it. Okay, which one is using HTTP 1.1, which one is using HTTP 2, which one is using HTTP 3, like that. Okay, cool. Reduce latency, yes, that means it is faster. We will understand these terms like latency and all in detail in next week, not right now. Yep, we will get to HTTPS, but first let's finish HTTP, then we will do HTTPS. Yes, cool. Can I go ahead? Right, HTTP 3 is not widely adapted yet, yes, because it just came in 2020, right? Cool. Now, in HTTP, there are some HTTP methods. Now, this is a question which is very, very important for system design interview. See, till now, system design interview, what are the important points that I told you? TCP versus UTP. And this is the next important thing that you need to understand, the HTTP methods that are there. Because when we do API design that we're going to do in our future classes, you will be asked to design a particular API, basically a request that you send. So you will have to decide that, okay, which method am I going to use? So there are different methods of HTTP request, and we will try to understand these now. Okay. So there are many methods, but there are 4 important ones that we need to understand. There is get, there is put, there is post, and there is delete. Now these 4 I want us to focus on, and I want you to tell me in comments the differences between these if you already know. When do we use put? When do we use post? I have been asked in an interview that when would you use put post? So Vikas has mentioned patch also. So when would you use patch? Right? So there are these different kinds of request methods, and you need to understand at when what is used. Let me try telling you now. Okay. So when we talk about get requests, okay, get request is basically you are just getting some information from the server. Guys, can I move ahead? Can I talk about methods? Just a quick yes. Everyone with me, everyone awake? Yes? Do I need to do a quick revision? We'll do after this. We'll do after HTTP methods. Is everyone with me? Can I get a quick yes, yes, yes? Awesome. Good, thank you. Now what we are going to do is we are going to talk about these methods. When we talk about get, what happens in get? So basically, first thing that we talk about is that we need to retrieve some data from data or some resources or collection of resources from server. Now, because we are just basically just getting or retrieving the data, one important point is that it should have no effect on server. So basically, when you send a get request, a server should just send you some data, and there should be no effect on the server. So basically, no data has changed inside the server. How it works, nothing should change inside that. Only then it is a proper get request. What is a get request? Again, just send some data to me. No change in server. It's a very, very important point. If you are making any change in the server, it should not be a get request. Okay, no effect on server. Very important point. Okay. Now let's go to put or post. Let's first understand post. So post is basically when you are submitting data. Here what you were doing, here you were getting the data. Here what you will do, you will submit the data. Usually when it is used, it is you create a new resource. You create a new resource. So if I am supposed to post some data, when I am signing up, I am going to do what? I'm going to send a post request. So you can actually see on Netflix when you try to sign up and when you do inspect, you will be able to see a post request being sent. You can actually see it. I was about to demo it today. Okay. So that is when you're creating new resources, right? Or when you're say submitting data, when you're uploading files, all of this we are going to use post, right? She is asking, shouldn't get method have body? No, get should not have any body. You are just getting some information, some header should be there. Okay. In post, a very important point is that you will always see content length. Otherwise, it will send you error. Now, this is another important point. Now, see, as like I don't want it to be all theoretical class, so I want you to make some effort also. So I am going to cover a few things and I want you to try these things and tell me on the Discord so that we can actually discuss this together. I want you to try, like maybe through Postman or through something, try sending a post request without content length, or try finding any place, try finding a post request where content length was not mentioned. Okay, so I want you to come up with these things and try understand that what happens. Is there, so in a HTTP request, you will always see some headers and we will see a body. So headers basically is key value. So it will be sent like this. You will always notice in raw. So there will be a key over here. There will be a value over here. So basically you're sending some information in headers and then in body you're sending some body. So does it make sense to have body inside a GET request? For beginners, if it is getting overwhelming, let me know. Like, it's fine. But like you can easily learn. You can easily catch up with this if you try to inspect. Okay? I will try to don't worry. I will demo it if not today, tomorrow. Okay? Post is submitting data. Put is basically what? Can someone tell me put versus post? I have been asked this in an interview. When would you use put versus post? In an API design, I was trying to confuse this put versus post. So in put, what we do is we try to update the data. We try to update the data as already present. And also one important point inside put is that the request is idempotent. Can someone tell me what does idempotent mean? Now suppose I am telling my server that for Kirti, now this is some new value which is 1 or 2. If I send it 10 times versus if I send it only once, it should have the same response, like it should have the same effect on the server. That is idempotent request. If I send the same request 10 times or if I send the request once, it should have the same effect on server. Versus the post was not idempotent. So basically what happens inside this is that if you add some, like if you send some data multiple times, maybe it is added as a new resource. How it is handled varies, but usually post is sent when we submit the data. See, if these points are not clear right now, I know I am covering theory, but we are actually going to design the APIs, right? In system design, that's what we are going to do. In our future classes, we are actually going to try designing our APIs ourselves. And when we do it, we will again discuss this. But you should understand that why are we putting put or why are we putting post. So it is not like I'm going to cover HTTP APIs only today. I'm going to cover it again. But this is just to get a basics, like, just to get you started. Yep. In delete, obviously what happens, as the name suggests, we are going to do what? We are going to delete specific resource from the server. Yes. Now after this, I am going to move to HTTPS. What I am going to do now is try to revise everything that we have done so far and then come to HTTPS. Okay. Put versus patch, you don't need to know so much for system design, but usually the difference is that it also updates, but it is not idempotent. So basically patch is not idempotent, post is not idempotent, but put is, right? So today's homework for everyone, try to inspect all of this. Try to send me screenshots on Discord. I want everyone to inspect different sites. At least try inspecting say 4 to 5 sites. Try to see the URLs. How is the GET request being sent and send me the screenshots. Okay. Now, quick recap of everything that we have done so far. We discussed client-server architecture, right? We discussed client is something that sends request. Server is something that responds to the request. Does something, responds to the request. Now see. This is very simple, like very simple thing that I've told you, right? This will get much more complex after this, right? So we need to understand it properly. Then we talked about that client and server are actually relative terms and it depends on the context. The same application server or web server that we have written could be client for some other request. Like for example, I'm sending the request to say my database server. Then what happens? It becomes a client at that time. Okay. Now what happens? After this, guys, keep the questions related to what we are learning right now. Random questions like about this channel and everything you can ask me after 11. Okay. Because I'm going to be reading the comments. So my focus should not get diverted. Try to ask the questions that are relevant to what I'm talking about. Yeah. Okay. Thank you. Now what we did, we talked about that networking is a very complex thing. We need to understand it, how it can be divided into smaller things, into smaller functions. Conceptually, we understood that okay, there are different frameworks. There is OSI framework, this TCP/IP framework. We don't need to know the details, but both the frameworks, everything has say two important layers that we need to understand for system design. One is transport layer and one is application layer. Then we understood that okay, every layer that is there, the lower layer basically does something from it, uses the info that only lower layer has already given, and it tries to help the upper layer. So basically upper layer uses the lower layers, right? Now transport layer, as the name suggests, we are going to talk about data delivery, the transportation of the data, right? It is going to cover about how we are going to divide our data into smaller segments and how it is going to be transmitted. Application layer is the topmost layer. So basically it works on top of the transport layer protocol, transport layer, and we talked about different protocols on both the layers. Transport layer, what are the common protocols? TCP, UDP. Application layer, what are the protocols? HTTP, HTTPS, FTP, SNMP, DNS, SMTP, a lot of them. Then we realized this will be too much information if we try to learn everything today. So then we focused on HTTP, HTTPS, TCP, UDP. These four were our main focus, correct? Then what we did, we started with transport layer protocols, which is TCP, UDP. Then we understood that how TCP actually works, because it's a very important point. You need to understand that why is TCP slower? What do we even mean by a connection, right? So we understood that it is a connection oriented protocol, but what do we mean when we say connection? So we learned that we need to establish a connection, do the data transfer over the connection, and then terminate the connection. So in order to make the connection, what did we do? We did the three-way handshake. First we said that okay, hi, I want to do the connection. Then the receiver said that okay, I acknowledge that you want to send that you want to connect, and then the sender said okay, acknowledged, now I am going to establish the connection. Connection established. Then we talked about how data transfer happens. There is segmentation, there is flow control, there is something called window size, and all that we discussed. We don't need to know the details. Then we talked about connection termination. I said that there could have been some abrupt connection termination which is out of our hands, and there is something called graceful termination. Basically, it is a four-way handshake. What will we talk about? First, we're going to so important point, the termination could happen from any of the sides. It could either happen from client side or from server side, right? So whoever is the initiator is going to send a fin request that I want to finish, I want to stop the connection. Immediately the receiver is going to say that okay, I am going to do what? I am acknowledging that you want to finish. Then it stops its own processes, does something, then says okay, I am also ready to finish. Then it acknowledges, both wait that okay, there are some packets to be sent, and then they close. This is called a four-way handshake. Then so basically what all we have learned? We have learned about TCP handshake, we have learned about how data transfer happens, and we have learned about four-way handshake. So we know about how TCP works. Now we know why it is slower, because it has the overhead of establishing the connection, maintaining the connection, terminating the connection. Then we did something that is extremely important for in terms of system design and interviews, which is TCP versus UDP. TCP is what? It is connection oriented. This is connectionless. Then we learned that it has overhead. It has no overhead, so obviously it is faster. This is reliable because we are guaranteeing the delivery. If it doesn't reach, we are going to do retransmission. Basically, someone was asking what retransmission means. So basically, if it has not reached, if I have not gotten an acknowledgement from the server, I am going to send it again. That is retransmission. It is reliable. I guarantee the delivery. So that is what FedEx people and all these do now. It is not going to get lost somewhere. If I am sending my parcel, it is going to reach, right? So TCP is reliable, UDP is not reliable. Then because TCP is so reliable, again what we are doing, we are doing error checking, extensive error checking. Here is just basic error checking. Here we are doing sequencing ordering. Here there is no sequencing ordering. Obviously this is slower, this is faster, this is safe, trustworthy, this is just quick. So we saw some examples. Then I talked about broadcasting. Broadcasting is supported in UDP, it is not supported in TCP. Yep, all good guys. TCP versus UDP clear. Quick revision happened. Now what we did, we talked about the application layer protocols, which is HTTP, HTTPS. HTTP, I just told you that how it got evolved. Initially it was just a GET request, then it was all over TCP, then something called QUIC came, and it can also be over UDP. So HTTP 3 is over UDP, HTTP 1, 1.1, 2 is all over TCP. Yep. Going through the comments, Tori is asking, can we see these connection, this handshake in network tab? I know the request, so you will not be able to see the TCP connection. There are ways, but you will basically you will see HTTP request. Oh, there are ways, but not going to get into that right now. Yep. Now what we did, we talked about the different methods, which is get, put, post, delete. This is not the end of the method discussion. We are going to be discussing them in detail, and I am going to show you more demos. Cool. Now what we are going to do is we are going to go one level up, and we are going to talk about HTTPS. Can you all tell me what does HTTPS stand for? Why do you think we need HTTPS, and how would it work? Yes, awesome. So basically HTTPS, as you all are already telling me, it is a secure version of HTTP. Now what does secure even mean? In very simple terms, all the communication that is going to happen, it is going to be encrypted. What? Encrypted communication. Okay. So we are going to do what? We are going to ensure the confidentiality and integrity of data. Yes, so everyone I can understand the secure version of HTTP in encrypted communication. Yes. Now what we are going to do is story time. Okay. We are going to learn something very interesting, not extremely important for system design, but if you understand it, it is going to be very, very helpful. We talk about encryption, right? So how does encryption actually happen? Let's try to understand that, and things will become much easier after that. Everyone with me? Everyone excited to understand how encryption happens so that HTTP is completely clear? Yes? Because you must hear a lot of big terms, but once and for all, let's try to understand how encryption happens, and we will understand how HTTP works. Okay? Yes? Great. Everyone, have a sip of water. Be with me. First class, come on, keep up the energy. We have to learn so much. After this, you would be awesome at networking. You will be able to answer the detail level questions, and no one will be able to question you after this. Yes? Great. Thank you. Really like the energy, and you have to keep up the energy all the classes. 5 weeks you have to show up. Okay? It's not just the first day when I want to see this energy. Very good. Now what I'm going to do is I'm going to talk about encryption. There are two types of encryption that you must have heard. As one of you, as Deepa has already said, very good. So there is something called symmetric encryption, and there is asymmetric encryption. Right? So let's understand what happens in encryption and decryption. In encryption, we usually need a key. In symmetric encryption, what happens is the same key that is being used on both the ends. So firstly, we are going to encrypt some data, and then we are going to decrypt it, right? So it's the same key that is being used. Okay. But here what happens is that here it is different keys that are being used. Right? So different keys for encryption and for decryption. Now while working, like you must have heard of something called a public key and a private key. Right? So that's what we are going to understand now. The concept of public and private key is actually very interesting. So these two are very mathematically linked keys together. So mathematically, these two keys are generated together. One is called a public key. You will see this a lot while working, and one is called a private key. Now what happens is that this public key, this is given widely to people that you use this for encryption over here. For encryption, what will be used? Public key will be used. But for decryption, what will happen is that only that private key will be used. So public key will be what? It will be widely available. It is public. Private key is what? It is only owner knows, only it is there for decryption. Yes, Angad is saying there are no fun examples. Okay, how do you want me to make the networking fun? Try to give me some tips and I will take it up, right? So after every class, by the way, I'll just take a minute. After every single class, you can give me feedback on Discord, on mail. There is support at the kirtibasaricourses.com. There is you can rate me, whatever you want to do. Okay, so every teacher has a different teaching style. This is my teaching style. I will try to repeat everything as many times as possible, but if you prefer being taught in any other way, tell me, because it's a 5-week course, right? You are here with me for what, 3 to 5, 15 days. So try to give me feedback after every class. I will try to improve. Okay, symmetric versus asymmetric encryption. Asymmetric encryption, there are two keys, public key, private key. Public key is public. It is widely available. You use it for encryption. Private key is private. I am going to use it for decryption. But the interesting point is that these are generated together. And mathematically, it is not possible to compute private key from the public key. Right? So it is not possible to get private key from public key computationally. It is very interesting mathematically if you think about it. So you have a key that everyone has, but you cannot derive private key from that. Okay. Now what we are going, so see, here the problem is that, okay, I'm just reading the comments. Okay. Now here the symmetric ones, what happens is that it is computationally more efficient, but because it is more efficient, for large amount of data, so it is more efficient. But the problem over here, can you guess the problem that happens with the symmetric key? Same key has to be with both the parties, right? For the encryption and the decryption. So the same key should be available. So you have to find a way in which you can pass the key to the person for decryption also, or for the encryption, right? So here the problem is that you have to make sure that your key is safe, correct? But here what happens is that because different keys, so you don't have to worry about the security so much, right? Because it is there. But what happens over here is that this is more expensive. Okay, quickly. Symmetric, computationally better, faster, better for handling large amount of data. But what is the problem? The problem is the key has to be transferred to the other party. Here asymmetric, key can be easily handled and everything can happen. But the problem is it is expensive, it is computationally more expensive, it is not better. Again, trade-offs. So what HTTPS does is, now comes the interesting part. HTTPS is very smart. Initially what it does is, to exchange the key for the symmetric one, because we want to transfer the large amounts of data and we want it to be faster, we want it to be more efficient. So what we do is that for this efficiency, sorry, I am writing it again. We want it to be efficient and we want to use the symmetric one, right? But to pass this key, what it does, it uses asymmetric encryption. You understand how smart it is. So basically we know that symmetric is better. We want to do it. But how to actually safely send that key? Now for that, asymmetric encryption is used. Does it make sense? You obviously do not need to know so much of details, but you need, I thought it would be something interesting to explain, so that's why I covered this. So basically there are two types of encryption. One is symmetric, one is asymmetric. So what HTTPS does is that it uses symmetric, but initially for the first time to transfer the key, it uses asymmetric. Yep. Now what we are going to do is we are going to talk about how the HTTPS actually works in detail. So again, it has, so basically there is a client, there is a server. So there are a bunch of things that happen. Okay, some people are saying please repeat. So just quickly going to repeat it. See, so symmetric, same key being used for encryption, decryption. Asymmetric, different keys used for encryption, decryption. This is more efficient, this is not very efficient, this is expensive. So HTTPS, it uses symmetric, but in order to pass the key, it uses asymmetric. Okay, simple. Now what client does is, like for HTTPS, client says hello. And in hello, the client says, so basically there is some level of security, it is secure, right? So there is something called TLS and SSL that is being used. Have you guys heard of it? SSL, TLS? So you don't need to understand the details. So can someone tell me the full forms of SSL, TLS? So basically it tells that these are the versions that I support. So client is telling server that these are the versions that I support. Okay, SSL, TLS. Server says that okay, hello firstly, and then out of these versions, I would like to support this particular version. Like let's talk in this version. Okay, I am waiting for you guys to tell me the full form of SSL, TLS. Come on. Okay, now what happens? First, the client says hello, says that these are the TLS, SSL versions. Then server says that hello, let's talk in this particular version. Then what happens is that this guy generates the keys, like because it has to do what? It has to use the asymmetric encryption. So it creates a digital certificate and it sends it to the client. Now what client does is it validates the certificate. So there was some certificate that came. Now client sees that okay, what is the validity, who has created it, who is the issuer, signature, all of that it will see. And then what it will do, it will do certificate validation. So basically it did the validation, and then key exchange is going to happen. So basically what we are trying to do, we are going to transfer the key for the symmetric transfer, the symmetric one, right? For the symmetric encryption, the key data will be used. Thank you for telling me the full form. Secure socket layer and transport layer security. Very good. Now, once you are done with the key generation, key exchange is done. After that, what will happen? After that, there will be one more request in which you will tell that, okay, after this, we are going to talk in this encrypted manner. And after that, there will be encrypted data transfer. So you obviously don't need to know all the details, but I thought it would be like once you understand how it is happening, you will never forget it, right? So what happens? Client says hello, it says that okay, these are the security versions that I support, SSL, TLS. Then what server says, hello, let's talk in this particular version, and it sends a certificate. Basically that okay, this is my digital certificate. Client is going to validate the certificate, and then key exchange is going to happen. What is the key exchange? So basically they are using the asymmetric encryption to transfer the key for the symmetric encryption. And after this, the encrypted data transfer will happen using the symmetric encryption, like say AES is a very common one. You don't need to know these details. It is just good to know information. Okay. In very short, you need to understand that HTTPS is just a secure version of HTTP. Cool? Yes. Certificate is basically from this, the signature, basically the key exchange will happen after that. So that is part of say asymmetric encryption to be able to pass the key, certificate is passed. Okay. Yes, it is issued by CA authority and all of that. You don't need to know so much of details. Cool. I hope you guys are feeling accomplished today, learned so much about networking. Yes? Okay. We are going to go one step ahead tomorrow. Okay, it is 10:45, but it is first class and I do not want to overwhelm you. Quickly, I want you to tell me how was the class and, did you like it? Any feedback, anything at all? Then we will get to the discussions. How was the class, guys? Did you guys enjoy? Okay, I'm making a video also. Come on. I am making a quick video. So, how was the class, guys? I would like to see the response. You don't have to tell me simply. You can just tell me if you did not like it. Any feedback, anything? It was good. Networking can be fun, right? Yes? Awesome. Yep. Thank you so much. Great. So, what we are going to do tomorrow is that tomorrow we are going to focus on real time communication and data exchange. Do not want the first class to be so overwhelming. Okay. So, again, okay, now quick things for you to understand at how the classes are going to work after this. Firstly, I will be sending you all a quiz, right? So I want you all to focus on quizzes, try to see that how much you are able to know, right? How much you're able to do. So I want you all to try solving the quiz and I will see that how much you were able to do, how much you were not able to do. Okay, I am overwhelmed by the comments. So good. Thank you so much. Okay, I will send the notes tonight. I will send you the quiz that I want you to solve today. Like I will have, right? So you can rate yourself. Any questions that you want me to pick up tomorrow, send me on Discord. What you're going to do today, you're going to try inspecting different sites. You're going to see the HTTP request. You're going to try reading more about it. Send messages on Discord, like literally just it is okay, bombard messages on Discord, spam people, but show that you're studying. Okay, let's push each other, let's try to learn as much as possible. I know networking can be very fun or very boring for some people, so it really depends on you, how much you want to put in. But once you get these concepts clear, you will never have to worry about networking for system design at all. Yep. If you guys think that we need a better platform, I could actually conduct the maybe classes on Teams. That also works for me. So don't worry about it, right? Quiz during session. So actually, see, the first class I did not know the speed, right? So it depends on like how much we are going to cover in the class. Depending on that, I'm going to customize the quiz and try to understand at what problems you were facing, and depending on that, I will give you the quiz. So for that, I will need some time till tomorrow, and then I will send you the quiz tonight itself. Okay. Yes, notes will be available on the content part. You will get the mail and everything will be available on Discord. So next 10 minutes for quick chit chat, right? Okay, how to inspect, by the way, try to right click on any site, literally on any site over here also you can right click on your Chrome browser. Try open Chrome browser on your laptop, right click, inspect. There would be some sections, go to network, you will be able to see. Otherwise tomorrow I'm going to demo it. Okay. Awesome. I hope, yes, teach with daily life examples. So see, now that you've understood the concepts of TCP, UDP, you will be able to understand the daily life concepts. See, when we are sending email, what transport layer protocol would you use? When you are talking over Zoom, what transport layer protocol would you use? Right? So you should be able to answer all of these questions. Yes? Yep. Awesome. Any other questions? Any other thing? Anything else that you would like to say to me? Netflix, HTTPS, yes, very good. I will teach with a lot of daily life examples. Don't worry. This was basically TCP UDP. This is a lot of theory, right? So I need to teach you theory to be able to reach that level. So as you spend more time on system design, it is going to get more and more fun. Especially for DB part, you will be able to see so much. Like we will talk about Cassandra, we'll talk about SQL, NoSQL, we'll talk about MongoDB, about different things. It will be fun. Symmetric, asymmetric, say authority, I need deeper understanding. Can you please reference material? Yes. Can you please remind me on Discord? I will send it to you. Okay. Cool. All right. Okay. Thank you so much for all the feedback. I will take it up. need a 5 minutes break between the hours. So what we can do is we can try talking in between like this, or we could like do a quick recap, right? The timing cannot be changed now because some people must have signed up only saying the 9 p.m. time, right? So they would be free only at 9 p.m. It is not possible to change the time now. The time will be 9 p.m. to 11 p.m. This was kept because I thought that you will be able to finish your office work or college work and then join. Just 5 weeks of hustle, guys, and you'll be done with system design. Come on. Right? Bottom of my screen is hidden. Okay. All of this will be sorted. Just give it 2-3 days. Need to visualize concepts. Yes. The timing is actually perfect. Great. Small explanation of quick. So basically built on top of UDP. It solves the problem. It is basically a better version of TCP and UDP. So it solves the problem of TCP taking a lot of time, being slower, and it solves all of these issues. It is also reliable. Yep. Great. Awesome. Thank you so much. Yep. Great. You can just choose high quality data server. All right. See you all tomorrow, guys. I hope you will show up tomorrow also. If you have any questions, okay, I'll be here for next 10 minutes. Whoever wants to stay for the chit chat for answering the questions, I can answer. Okay. Yes, after this course, I'll be taking LLD. Yes, the registrations are still open. So if any of your friends want to register, you can just let them know. They can still join. Also, if you all want, you could like take pictures, put on Instagram, I'll share, or put on LinkedIn. I will come comment, give you more reads, and probably, like this, we can form a better community. Guys, be active on Discord, Insta, LinkedIn, anywhere. Try to make this huge. The more you motivate me, the more I will be able to give it to you guys, right? Yep. Yes, reference material, I will give it to you. I will give you quizzes, I will give you notes, everything I'll give you. Okay. Out of today, what all things you need to know for system design interview is majorly TCP versus UDP. Understand the transport layer, application layer, HTTP versus HTTPS, HTTP, various methods, and when to use what. So all of these things you need to know. Okay. Cool. Create any good book on HLD? That's an interesting question. I will look into it and I will let you know what books you can actually check. Yes, low level design will be after this. Language, I am yet to decide. C++, Java, I am seeing if we can do both together some way. Yes, list of topics that I'm going to cover in a session is already available on the site, so you can actually see the week-wise curriculum. The content also on the site, you can see that I've created, I've already scheduled the classes, right? So you will be able to see that, okay, what I'm going to cover in which class. LLD course is going to be different from LLD bootcamp. It is going to be a much, deep, like it will be more depth, like we'll cover more depth. We'll cover a lot of examples. We'll cover more design patterns. So in 3 days in the bootcamp, I covered the necessary things. Here we will spend more time on examples. Probably we'll take 4 to 5 examples, and we'll also cover, say, more design patterns, everything. I've not decided the language of the LLD, guys. Yep. Any other questions? Siddhant has already suggested a book. Yep. I hope DSA practice probably after LLD. I feel there are a lot of people who are already doing DSA. I would love to do DSA. Like I already did recursion and dynamic programming, and the response was great. So what I'm going to do is probably after this, after HLD, then LLD, then DSA. So do need a lot of support. I will be able to do this only if you try to share with your friends. So can I expect you guys to share on Insta and LinkedIn today? Yes. Will you try to motivate your friends to join? LLD course, guys, I have not structured the LLD course yet. I take a lot of time in structuring my course. So I have not structured it. My HLD course, I took weeks to make sure that how I'm going to teach, what exactly I'm going to teach, right? So, yep. I will cover more about SSL TLS tomorrow. A lot of people are asking, like, is it a layer? What is it? We'll cover tomorrow. Okay. Yes, you will be able to see the recording right after this. It should be available. Okay. How to get started with jobs? It is a very, very broad question, guys. Like, I can speak on it for like hours and hours. Uh, we'll cover it later. Okay. Graph sessions, yes, we'll have. Reading material, yes. Notes, yes. The more I talk to you, the more I understand what you guys are looking for, honestly. Month required for LLD. So my LLD course will be focused on a lot of examples. So uh, I will make it like a 5 week, 6 week thing probably. Yep. Yeah, if I start with TSA, I'll probably start with recursion dynamic programming and then probably graphs. Yep. I want you all to tell me on the Discord what were the things you learned today. Share on Insta, share on uh, LinkedIn. Yes, I want you also to get a better reach. It actually helps you get jobs if you actually put on LinkedIn, and people will see the credibility that you have actually also done this. Uh, DSA before LLD, not sure. I'll see. LLD super good. Awesome. Probably we'll do a poll LLD versus DSA. We'll see. Cool. All right. Networking, how much is sufficient? So basically, whatever we are covering in the class, I'm telling you today also we covered a lot of extra things. Remember? So I was telling that this you need to know, this you don't need to know. Like I was telling you that how HTTPS works or how the encryption decryption happens, you don't need to know. Like the handshake and all, it is good to know information. No one's going to ask you them in the interviews. What is good for interviews is basically TCP, UDP, HTTP, HTTPS. You need to understand the different methods. Yep. Cool. Awesome. Okay. Go sleep, everyone. Thank you so much. And I want I want the energy up all the 5 weeks. It's not like on the first day you are coming up, and I want the energy to be maintained. If there were 295 today, I want 295 every single day. Can I get that as a promise? Yes. Will you show up tomorrow on time, sharp 9 p.m.? Yep. Yep. Please, can I trust you guys to be very, very regular? Let's try to do this together. Awesome. Excited, guys, excited. Chalo. See you tomorrow. Have a very, very good night. Thank you for showing up. Great talking to you all. We'll talk more. We'll keep talking. We'll keep connecting. है ना? Not just us. Like आप लोग भी आपस में बात करो. Talk to each other. It would be fun.